Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this video, we're going to discuss one-sided limits. Let's start. Before we even get started on the definition of a one-sided limit, it's just common sense to ask the question, why are we even talking about a one-sided limit? Because according to the definition of a limit of a function, the left-hand limit and the right-hand limit both must exist and both must be equal. Left-hand limit must be equal to the right-hand limit, and that is the limit of the function. So why are we even talking about a one-side limit? Well, the answer to that question will become more clear when we discuss topics like continuity, where we have to talk about, the continuity, the end point of an interval, of a closed interval, or if it's closed at one end of an interval, one end closed and the other end open. So the end point of an interval, wherever it's included, the definition of continuity is based on limits. And limits, therefore, is the heart of calculus. Even when we talk about differentiation, you'll be using limits to define that. So the end point, especially when you have a closed end, if it's closed at one end and open at the other end, or if it's closed at both ends, the closed end, if it's A, comma B, or A, comma B, the end points of an interval. And so it becomes important to understand what is a one-sided limit. Okay, so the definition of a one-sided limit is like this. A one-sided limit is the y value a function approaches as you approach a given x value from either the left or the right. Notice the keywords. We've got the word approaches again, but we've got a new word here, either. When we were defining the limit of a function, we said both the left and the right hand side. But this time the one-sided limit is defined as the y value a function approaches as you approach a given x value from either the left or the right. Okay, not both ends. So in that sense, if you look at this example now, okay, look at this graph. Again, a piecewise function. The limit of f, can you see this? All right, the limit of f as x approaches 3 from the left-hand side is 1, as it says in the statement. Okay, let's look at it graphically. The limit of f as x approaches 3 from the left-hand side. This is 3, okay? From the left-hand side means x approaching 3 from the left-hand side is here. The graph, watch the graph values. The function values are coming, and it's coming close and closest to -1, and that is what it says here, okay? So that's -1. The limit of f as x approaches 3 from the left-hand side is -1, as you can see, okay? It's approaching -1. And the way we write that sentence, the way we write this is this notation. Look at this, okay? Limit f of x approaches, that arrow means approaches, but can you see the 3 with the negative sign? X approaches 3, the negative sign at the top. That means from the left-hand side of 3. So the negative on the top of 3, that refers to the left-hand side of 3. So the sentence is the limit of f as x approaches 3 from the left-hand side. Left-hand side of 3 is negative, and as we saw that on the graph, okay? And the second sentence is the limit of f as x approaches 3 from the right-hand side is 2. Okay, let's just check it on the graph. Right-hand side of 3, this is the right-hand side of 3. X approaches 3 from the right-hand side of 3. And the function values, if you follow the function values along the graph, it's approaching 2. Can you see that? That's the value 2, okay? That's the value 2 here, all right? So that is correct. And the notation, can you see here now? All right, 3 plus, all right? So that is like saying x approaching 3. And the plus sign indicates values of x approaching 3 from the right-hand side. Minus sign, 3 minus means x approaching 3 from the left-hand side. 3 plus means x approaching 3 from the right-hand side, okay? So this is the notation. These are notations for the one-sided limits. Let's illustrate this with an example. Here we have a graph. It's a piecewise function, and we need to answer these questions based on the graph that is given, okay? So limit of f of x as x approaches -2, and the minus on the top of -2 means we are talking about the values of x approaching -2 from the left-hand side of -2, okay? So the left-hand side of -2. Let's go back to our graph here. Left-hand side of -2 here, okay? X is approaching -2 from the left-hand side, and the values of the function, as you can see, they are coming closer and closer to 1. So the answer, it's not equal to 1. We're just interested in what's approaching, okay? So that's 1. Next one, limit x approaching -2 from the right-hand side. That plus means right-hand side of f of x, okay? Let's look at that. Right-hand side of 2 is this, okay? And that's from the next the other piece of the function. Okay, so it's coming from here, the function value is coming here. It's not equal there, that's okay, but it's approaching -2. It's approaching that value. So the limit as x approaches -2 from the right hand side is -2. All right. So part C says, what then is the limit as x approaches 2? There's no plus or minus. That means you're talking the limit of the function. Now, clearly, left-hand limit is not equal to the right-hand limit, which means we can say the limit does not exist. Okay? Next example, limit of f of x as x approaches 1. There's no plus or minus. We're talking about the limit of the function as x approaches 1. So we need to consider both right-hand limit and the left-hand limit as x approaches 1. Let's look at the graph. Right-hand limit, as x approaches 1 from the right-hand side, the function values, can you see the function values are approaching 1? And as x approaches 1 from the left-hand side, the function values again seem to be approaching 1. It's not equal to 1. The function is not defined at x is equal to 1, but that's okay. The limit is basically what the values approach from both ends, and they're equal. So the value of the limit as x approaches 1 is 1. Interesting. Next one. Limit as x approaches 0. Again, there's no plus or minus, means we are talking about the limit of the function as x approaches 0 from both ends, left hand, right hand, both ends. Okay, so f of x. Here we come to the function again. I'll have to clear these colors so that we can see what's happening at 0, right? So here we go. Right hand side of 0 as x approaches 0 from the right hand side, the value of the function is approaching -2. I need to clear this thing also so that you can see it again, all right? So as x approaches 0 from the right-hand side, the value of the function is approaching -2. Can you see that? And then as x approaches 0 from the left-hand side, the value of the function, again, this piece is approaching -2. So the limit of the function as x approaches 0 is a -2. Cool. Now, x approaches 3 and then minus on the top. Here we are talking about the left-hand limit, okay? X approaching 3 from the left-hand side. X approaches 3 from the left-hand side. Okay, I'm just going to clear this shading again so that it becomes a little clear. That's 3, and x is approaching 3 from the left-hand side, okay? Values of the function are approaching 5. So this is 5. All right? Now, x is approaching -1. The limit of f of x as x approaches -1. Again, there's no plus or minus. You're talking about both ends, okay? Left hand and right hand. -1, is it -1? Yeah, it's -1. So here's -1. And let me use another color. -1 from the left-hand side. You're looking at the values of the function. Here, it's approaching -3. And from the right-hand side of -1, the values of the function are also approaching -3. So again, the limit is -3, okay, because both the left-hand limit and the right-hand limit appear to be approaching -3 from both ends, okay. Now, limit as x approaches -3, limit of the function as x approaches -3. So I need to clear these colors again, one more time. That's okay. You can pause the video, rewind the video, and watch this thing again, okay. So as x is approaching -3 from the left-hand side, the function is approaching 0. And as x is approaching -3 from the right-hand side, the function again is approaching 0. Function values are approaching 0. So the value of the limit as x approaches -3 from both ends happen to be equal to 0, right? F of -2. F of -2 is just the value of the function at -2. At -2, here's -2. There's a hole if you're looking at this, and that's where the value of the function is, okay? That's where it's defined. So the value of the function at -2 is 1. Okay, what do we have next? F of 1, the value of the function at 1. The value of the function at 1 in the same way is -2 here. Okay, so -2. So from this one example, we've seen that the limit of a function will not exist if the left-hand limit and the right-hand limit are not equal. When we see a question like this, when does a limit not exist? We can safely say when the left-hand limit is not equal to the right-hand limit, the limit of a function does not exist. But there are 2 more points. There's 2 and 3. We just have considered one case when the limit of a function does not exist. What are the 2 other cases when the limit of a function does not exist? We'll see that in the next video.